Hello world, welcome to Net More Than Tech Academy. This is our fourth episode in the series of learning how to solve a maze with Python, PyGame, and backtracking algorithm. Going back and looking at our steps, we have completed all the above steps 1 to 5 in the previous 3 episodes. If you have not watched those episodes, please click the link on the description and watch them before continuing here. In this episode, we target to make a simple PyGame to display our maze in a better presentable way. To do this, we're gonna start a new applet and we're gonna make a PyGame applet. So let's create a PyGame and let's get all the basics of our PyGame done. Most of the code is generated here already. We have the width and the height set here already. Let's just run this and see if everything works good. Perfect, it looks good. I just need a few more things here. I want to make my width and height variable. So set it here. So width and height. Okay, that's good. And we have our display surface here. And next thing that we want to do is we also want to use the clock here whenever we do PyGame. It's always a better idea to have the clock so we control how fast the frames refresh. So let's do clock tick and let's say 60 frames per second. So let's run this and see if everything is good. Yes. To make a empty black screen, let's fill the screen with something. So let's use our display surface here and fill it with color, black. Let's make sure everything is working. If I change this to white, I should see the screen. Okay, good. So that's our screen. Perfect, good. Now here is our code that we used in the last episode. We have our whole logic of maze written here, and we have maze text here. So we need a maze text here as well. So let's recreate that file. And with respect to the code that we wrote here, let's bring it in here, but let's put it in a separate file, maze.py. Okay, good. And with respect to all these variables that we used here, we will need them in our main program here. So let's create all the maze variables here. And the first thing we want to do is actually load the maze. So let's go back to our maze program. We don't need this while loop here anymore. All we are going to use from this file are these functions. So the first function we need is the load maze, which is going to return all these values. So we just need this one, and let's call our load maze function from the maze file. So to use the maze file, we need to import it. So let's import maze and let's call maze dot load. The function name was load maze. So let's run this and make sure everything is working. Okay, so here is a problem. We created a variable named maze, but we also named this file maze. So let's rename this and let's call this maze logic.py, and let's change this to maze logic SML. So we change this to ml dot load maze. Let's run this and see. Okay, now our maze load is working fine. Everything looks good here. We have got all our variables here. Looks good. In our maze logic, we had the print maze function, which will actually print the maze to the screen. We don't need to call this code here. So let's stop and run this one more time. Okay, everything looks good. Let's make sure our maze got transferred here to our PyGame code. So let's stop and run this. Okay, good. We have everything that we need. We can also call the print maze function from here to check if everything is good. So to call the print maze function, we need to pass all these parameters. So let's go back here and just use our library and call the print maze function. So that should print our maze. Perfect. Everything looks good now. Now all we have to do is draw this maze into our PyGame window. And now let's see how to do that. So let's make a function called draw maze. And we need the maze, the number of rows, and the columns. Yeah, let's go. All we have to do is loop into our maze. So for R in row, C in column. So how we are going to do this is we are going to draw a box for each cell, and we are going to color code each cell based on whether it is a free path for us to go, or is it a block, or is it our target or a player. So we need a few colors to work with, and we also need to fix the size of each cells. So to calculate the cell size, it's going to depend on the width and height of our current screen. So let's make a variable. Cell width will be the total width of the screen divided by the number of columns we have. That will help us decide the cell width, and cell height is going to be the total height of our screen divided by the number of rows. That's good. Now that we have our cell width and cell height, let's first draw a simple rectangle and see if everything looks good. So I'm gonna do pygame dot draw dot rect, and in order for me to draw a rectangle, I need to say in which screen I want to draw my rectangle, which is going to be my display surface. And then I need to say my color. For example, here I'm gonna keep it gray for now. I will have to tell the exact location. So where should it start? It should start based on my cell width and cell height. So whatever column I'm in times the cell width, and whatever row I'm in times the cell height, and all my cells are going to be the same width and height. So cell width, cell height, HT. Okay, good. So now this should draw me the number of a number of boxes or cells. So let's see if everything looks good. So I need to call the function to draw it. Let's try and call it here. So draw maze. So we pass the maze, the row, and the column. So let's try to run this. Okay, we have run into an issue here. Int object is okay. I should use range here. Let's try that one more time. Good now, but my whole screen is gray. I filled the whole screen. I do not able to differentiate each cell. So let's try to add a border, and we can do that by passing the width parameter here. Let's try and pass 5. Let's see how it looks. Okay, good. So we have our cells here, which is good. And now let's actually make it, let's say, 1/3 of the total width. Okay, that looks all right. And 4th. Okay, much better here. So I should have 10 rows and 10 columns. Okay, looks good. Now what we have to do is we cannot make all of them gray. We need to check what type of cell it is and draw it accordingly. So we need some if conditions here. If maze RC, let's say, is the player, I want to do the same, but this time my color should be blue. And let's put this in else, and let's see how this looks. Do I see my player now? Okay, perfect. I do see my player here. Now let's go back to our files here, and let's try to change our player to a new position somewhere here. And let's try to run the code again to check everything looks good. Yes, now my player is on the top. Okay, looks good. So the color varies based on what type of cell it is. So let's make a variable here, cell color, and let's always keep it gray. And if it is a player, then I'm gonna change the cell color to blue. And I will always draw a rectangle, and the color will be whatever the cell color is. LF, the current cell, is actually my target, which is 5. I'm going to set the cell color to 3. So now let's try to run this one more time. Perfect. I see my player here. I see my target here. So 1 and 5. Let's change our target and check everything. Looks good. Perfect. Now all we have to do is find a color for other things, the path, the dead end, and the wall. So LF maze root column is a wall. Cell color is going to be red. So we need to do the same for our dead end. I'm gonna make it, let's see, and path. I'm gonna keep it. Let's say pink. So now let's run it. Okay, perfect. Now we see our maze. This is our player, this is our target, and we see all the balls. All that now we have to do is call our move functions to solve the maze. Perfect. So how did we solve the maze previously? We had a loop, and inside the loop, we got the order in which we want to try, and we did everything. Okay, so we have to do the same. We don't have to create a loop for PyGame though, because the loop is still already running. So all we have to do is add this logic. So let's copy this piece of code and bring it all into our PyGame. Let's uncomment the code. So if our player has reached the target, we will say success. Let's keep it as is for now. We need a move made variable that we create on the top. So let's put that one there. And we just have to call our maze logic function. Maze logic function. Maze logic function. Logic function. Okay. So everywhere we print the maze, we actually have to draw the maze. So now let's see how this one works as is. So what are we doing? We are checking the target, we are breaking the loop, we are finding the order in which we want to move. We check if it is a valid move, we make a move. If we did not make a move, we backtrack, and everything else is the same. We might have to draw the maze every time we change the maze, so which will be after we print the maze. So let's call the draw maze function and let's see how this works. Let's run this. Okay, perfect. That's good. We can see all the dead ends that we met and how we actually reached the target. That's surprising. It worked in the first attempt itself. Let's see if everything looks good. Let's try and change the target. And let's try and change our clock speed so it runs a little slower. Okay, perfect. So we explore our the path, and that's how we solve the maze. That was very interesting for me to solve and to also make a video out of it. Hopefully you also enjoyed this whole journey of solving the maze over the past 4 episodes. I will meet you all again with another interesting problem. Thank you everyone for listening. Bye world.